Okay, so let's start. Here, I'll guide you through another type of infrastructure, basically the coaxial infrastructure that's been deployed for broadcast cable TV. And first part, I will show you the kind of footprint that we have in that kind of infrastructures as Prismian Group. And then I will guide you through what we made to accompany those operators migrate towards broadband transmissions on their infrastructure. This is another way, again, back to what Alessandro commented on the X factor. This is also another way of bringing in the fiber closer and closer to the end user and then leveraging the latest drops that are available. And here is going to be on the coaxial infrastructure. So what's a cable TV infrastructure? Basically, you have a headend where you receive your channels, and then you distribute this through a trunk, a cable trunk, a coax trunk, to the end users. So you have different taps here, then drop cables connecting the different premises. And then the migration towards what we call the hybrid fiber coax, or the fiber to the last amplifier, by putting a piece of fiber cable between the head end and a remote node. And depending on where this remote node is in the network, it's going to be hybrid fiber coax or fiber to the last amplifier. I'll guide you through this. So a bit of terminology. Okay, CATV, community access television, community antenna television. Basically, it's about broadcasting channel different content on the network. So it's initially was created to be unidirectional, so not bidirectional interactions. Really, broadcast from the head end to the end users. And then, of course, drop cable is the same terminology as in FTTH or any other configuration of a network trunk between the head end and the different taps. In terms of layers, a bit of clarification, because the layers here are not the same as what we call in the OZ layer 1, layer 2, layer 3, the switches, the applications. This is a bit different here. So layer 1, basically the content broadcasted from the satellite to the dishes. Layer 2, at the receiver side, where the dishes are, basically at the head end. Then, where we play ourselves as Prismian Group, the transport layer, and the user, the premises connections. With here, for instance, an example of coaxial patching, cabling at the head end. The trunks, so basically big coaxial cables that are laid alongside the roads, and distribution, a bit looking at same type of terminology and topology as we had before for the fiber drops. So as Prismian Group, we have a former DRACA part that's called Multimedia and Specials, MMS, that really deals with all this cabling infrastructure for coaxial trunks or coaxial drops. You cannot read anything here. I'm sorry for that. It is just, a series of trunk cables that are available in a number of dimensions, and also very important, the quality of the screening. So we have advanced designs that are proposing screening up to over 100 dB, and even super designs screening over 120 dB. So this for the quality of transmission. Same applies for the drops. So regular design, advanced, super. Here the screening, the different level of screening are a bit reduced. You have a bit 10 dBs less, but still these to guarantee premium transmission, distribution, and other values from regular 80 dBs to 110 here. And again, available in a variety of sheath designs and screening types. I'll not spend much time on it. The way we name them, basically coax for coaxial, We have here the attenuation per 100 meters at a given frequency, 230 megahertz. And then whether the conductor is copper or aluminum, the diameter of the inner conductor, and of course the grade of screening. And what's very important for coax is also the coupling between the inner conductor, the outer conductor, and the connectors on the edges to basically ensure the reliability and the durability of the deployed network. And for that reason, we don't produce the connectors ourselves, but we do recommend some connector houses that are working, that have been tested and work fine with our drop cables. And so we do have that kind of recommendation also for these infrastructures. Other things that we've been doing, exactly the same concept as the pizza box for fiber to the home that was just presented earlier by Alessandro. We have created, okay, I would say a bigger pizza box, but a kind of a packing, special packing for the drop to ease the installations for the installation team in the different premises. A few references. We have, in Europe, there are some countries, for instance, here, Belgium, where the cable TV is very, very much present. Some countries, you hardly have cable TV networks or legacy. In some others, really depending on the history, you have some very well broadcasted CATV networks. And Belgium is one of those. And we've basically accompanied Telenet, provided all the trunks, the drops. We are top player out there. Another big one is Turksat, where we also provided the trunks and drops and accompanied them to migrate towards hybrid fiber coax and fiber to the last amplifier by providing hybrid cables with fiber. I'll come back to it. Another thing is we're also very, very much present in the top grade of that kind of studio cables, broadcast cables, because when it comes to taking the images where the source is, the cameras, when you are in an event, World Cup, whatever, rugby, soccer, or Olympics, you need to have top quality images or content, because then it's going to create a bank of images that will be broadcasted by all the channels, so they're in common. So what you shoot from the cameras, the HD cameras, need to be of top quality. So those are high precision 75 ohm cables, coaxial cables also. And as in our organization, we've accompanied most of the major events recently, the Olympics and the World Cups. So soccer World Cup. So really something we do very well, those coaxial cables. So starting from this coaxial background and all our knowledge also in optical cables, combining the two, how to accompany the operators in their migration to how broadband, higher rates on their infrastructure. Basically, the challenge was to make this infrastructure from unidirectional only, from the dishes to the houses, to bidirectional by combining also this data link, so using a cable modem here and at the head end, cable modem termination systems, with here a combiner, basically combining the analog broadcast signals with all the IP-related content, so the broadband. So here, we needed to rethink, and the operators needed to rethink their infrastructure. Okay, first, of course, implementing the CMTS that they get from Cisco or from others, the cable modems that they can get from a variety of vendors, ensuring that the two are properly interconnecting. But then, in terms of infrastructure, there are also things that you have to do to make this happen. And typically, hybrid fiber coax, I would say, high-level view, capable of 30 megabit per second, at least for the downstream. For the upstream, it might be a bit less. 30 megabit per second, and typically you have the head end, either directly or through a hub, connected to an optical node. So between the head end and the node can be between 5 and 40 kilometers of fiber in a cable. And then, starting from here, you re-switch to the coaxial world, and you can serve 500 to 2,000 homes. This area of homes served are called a cell, basically. So basically, you can serve 500 to 2,000 and 30 meg capable broadband traffic. And here you can still see the amplifiers, the electrical amplifiers, to cascade the different taps and drops and amplify the signals. You have the ultimate but now, topology architecture, which is basically pushing the fiber even deeper in the network and really reaching the last node here, the last amplifier. And in that case, you don't serve 2,000 houses, you just serve 100 premises. So the fiber is going here, optical node, and from here, you just reuse the different coax drops that are present in the premises you're connecting. Some solutions we've been proposing to couple both the coaxial trunk and the possible migration towards future optical architecture. That kind of designs, for instance, where you have the coaxial cable drop, and you just deploy empty microducts, where when you're ready, when you want to migrate your network towards fiber, hybrid fiber coax or fiber to the last amplifier, you can blow here some mini cables just to upgrade your network. And we also had created some configurations with hybrid coax trunk and some DSL copper cables here. I want now to focus rapidly on one case. It's a big one. Numericable is the main CATV operator in France, and it's been very, very involved in the broadband coverage inside France, bringing the high bit rate towards the end users. Why do I focus on this one? Because it's very typical and representative, and also because we have 100% or close to 100% market share here. We really accompanied this project from the very, very start and helped them migrate their network. And you will see the pace, it's been very, very fast. And when we look at those, this is the regulator, monitoring the electronic communications in France. And this regulator is issuing on a quarterly basis a monitoring of the home passed in terms of broadband and what broadband means, because in any country broadband is different, whether it is 10 meg, 30 meg, 100 meg. What they've decided to do is, okay, let's make two broadband, one 30 meg broadband and one 100 meg broadband, what they call the ultra broadband, but anyway. What I'm interested in is from a total of potential 31 users or premises that can be connected. At this moment, latest estimate, at least in March, the 11 million of premises were connected with 30 meg or 100 meg. And you can see here 3 million through fiber, that is to say real fiber to the home, using Verticasa, using all that you were presented earlier today. And you can see here 9 million served with these hybrid coaxial networks. That is to say fiber arriving deep inside the network and then finishing with the final coax drop. Again, to try and bring the broadband as fast as possible, leveraging the legacy infrastructure. And they've done that quickly. You can see here interesting percentage, because this percentage is now kind of stabilizing, because in total, I guess they have close to 11 million potential premises to be upgraded. So they are reaching the end, I would say, of the upgrade project. While here, the incumbent and the others are ramping up, and they are at 3 million with a very, very fast growing pace, just to reach the potential 31 million. So the slope is very steep for the deployment of fiber, and this one is just flattened because we are reaching the end. But it's interesting to see how we help this operator migrate their network. For instance, hybrid fiber coax. It's their view of the network, but really corresponds to what I've presented before. You have the CMTS here at the head end. Then you have the link optical fiber, the optical node, and then the coaxial drops. Very interesting here, exactly the same as what Alessandro mentioned for VDSL cabinets. You need power here. You need remote power from the head end. So what we've developed here is a series of, I'll show you, a series of hybrid cable again. So leveraging our expertise in metallic cables and optical cables, whether in aerial configuration or duct configuration, to be able to come here at the last amplifier. This is a box inside which you separate the conductors from the optical tubes, the optical fibers. Here in the cable, the duct cable I'm circulating, I guess, is 36 fibers. Here you have 2 tubes, so 2 tubes of 12 fibers, 24 fibers. And here you can see the red conductors and the black conductors just going up to the amplifier. So they are used for the power to convert the optical signal into electrical signal, and also to boost to pump the amplifier that will boost the signals that will afterwards be transferred through the coaxial infrastructure here. So reusing the drop that is present in the building, so all the coaxial infrastructure that is going to the different floors and serving the different apartments. So this is again, when you have to bring broadband quick to anyone, and when you're in a green field, you can go fiber directly. You can deploy verticasa, you can deploy fiber to the endpoint, to the last termination. When you have situations where you have copper drops that are present of pretty good quality, you can make XDSL, being ADSL, VDSL, VDSL2, plus the phantom mode, plus what's been explained before, the vectoring, or you can even reuse this coax infrastructure. So again, kind of a toolbox to be able to serve the different areas you are facing with the appropriate, always a mix between deploying new things and reusing the existing stuff with the same target, which is bringing broadband to anyone. Of course, at this moment, we are talking 100 meg, okay? 100 meg, those are, I mean, the hybrid fiber coax can do it when you bring to the last amplifier. Fiber, we are talking now 1 gig Ethernet, 1 gigabit per second at the end user. Okay, only fiber will be able to do that. Maybe a bit of GFast in the VDSL world, but GFast needs to be 70 meters maximum. So you'll reach a point for 1 gigabit per user and beyond, where fiber is going to be the final destination. But at this moment, there are migration paths for the different infrastructures, and still try and get 30 meg, 100 meg for the end users. This was it. Another presentations I wanted to make on these hybrid cables is just related to another infrastructure, which is mobile. Because mobile is another challenge. The operators are faced with very difficult situation where the average revenue per user, the ARPU, is not boosting, is not increasing like crazy, but the amount of data they have to deal with, the amount of broadband is just frightening. And it's been increasing like hell because smartphones are consuming typically 49 times the bandwidth of very old phones, I mean just voice. Tablet, 127 times, laptop, 227. These are figures taken from the Cisco VNI index. And those figures taken from Ericsson, you cannot see because it's very small, sorry. So last year, 6.7 billion subscribers for mobile. And they forecast that in 2019 it's going to be 9.2 billion users. It's a lot. Another thing that is just amazing is that the amount of IP traffic, you see the smartphone, they are not the biggest consumers, 49 times the voice, but still, since last year, the traffic generated by the phones, the smartphones, went bigger than the traffic generated by the laptop, the tablets, and the servers. And you see this red portion is even further increasing. So the operators definitely need to live with this duality of mobility and extremely high broadband. So how to do that? They need to think about new generation. So basically, the 2G systems for mobile are little by little decreasing. 3G has taken up heavily. And since the big commercial launch of 4G in Verizon, many other operators now are proposing. Here you have also some operators proposing 4G connectivity. 4G connectivity, and now it's already not enough. They are talking about LTE advanced. They are talking about 5G to be introduced around 2020. And no miracle again. You need to backhaul this traffic, to make the circulation of this traffic already between the end user terminal, the antenna, and between the base station and the core networks. And typically, LTE advanced, potentially you have links between 2 and 8 gigabit per second. Each base station needs to evacuate or to circulate or, deal with 2 to 8 gigabit per second of traffic. So fiber is becoming mandatory for those base stations. And we clearly see it. You remember this graph that I showed you in the morning with the violet part corresponding to what's called here metro. Well, metro doesn't mean anything. So it was such a big bulk stuff and consuming close to 40%. The analyst here, CRU, decided to split it up between regular metro loops and mobile backhaul. And when you look at mobile backhaul here, you see the amount of fiber it consumes. So your conclusion, your wireless is wired, and wired with fiber, more and more. Because when you see the amount here, almost as much fiber, as many fiber kilometers consumed in mobile backhaul than consumed in fiber to the home. It's a lot. Here, 2009, 30 million kilometers by China Mobile alone. 30 million out of 160 million fiber kilometers, it's significant, only for mobile and only for 3G. This was for 3G, not for 4G. And okay, what's been deployed for 3G, of course, will be reused for 4G. They are just upgrading the sites, but there is another challenge they are facing. When I talk a cell is a base station and an antenna. And depending on the generation, 2G, 3G, 4G, those are typical speed between the user equipment, and here the antenna, and here the backhaul, so the speed between the antenna and the core network, and very important, the cell size. Again, the coverage, because the more complex the modulation format that is used, the higher bandwidth you need to convey, the smaller the coverage. But the network operator cannot live with that. They just need to propose bandwidth to all on all the coverage. They need both. So what do they have to do? Increase the number of cell sites. So make smaller cells and really increase the density. Increase the density and with a lot of connectivity, which is, conclusion, fiber all over the place. Another point is inside building. Here I get the coverage is good. I could see, check my emails, the coverage inside is good. So probably this building is not a low consumption building. Because in low consumption buildings, all the waves are just kept inside. They cannot escape just to make the building energy effective. But the side effect of it is the wave cannot enter either. And in some buildings, the coverage indoor is just a disaster. and especially the latest conceived building. So what they do is the operators placed femtocell directly inside the buildings. So your telephone is getting to the femtocell inside, and then the femtocell is backhauled by the network inside the building, and then goes to the outside. So you don't need to cross the windows and lose 10 dBs or 20 dBs in crossing a window and go outside to talk to the macro cell. And this is important because in many deployments of fiber to the home, operators are proposing both a modem, a termination for the triple play, and a femtocell embedded in it. So basically reusing the same network for both the fixed and the mobile, the indoor mobile access. And another trend we see, so for sure we are convinced the backhaul means collecting the stations need to be fiber. But more and more, the link between the baseband units and the antennas, there used to be coaxial cables, again coaxial, these big feeders, two functions for the feeders, power again, and data transmission. These feeders, they need to be replaced little by little by fiber also. That's what we call fiber to the antenna. So the front haul means not the back haul, not after the base station, but between the base station and the antenna is getting more and more, uses more and more fibers. And then maybe ultimately, at least they are thinking about it for LTE Advanced or 5G, try and put all the base stations together, so get rid of the model of a base station and antenna, a base station and antenna. Just co-localize, put all the base station, the baseband units together in something like a central office, and then distribute through an optical distribution networks over fiber, distribute the signals toward the remote radio heads. Okay, this is, I would say, next generation because it's complicated. If you lose in a PON system, fiber to the home, if you lose a link, you lose few customers, okay? Here, if you lose a link, you lose all the antenna. So a cell is what? Is several hundred users, and it's going to be very difficult to replace. So here, you need to think about the resilience of your network. So it's not going to be for tomorrow, maybe for tomorrow, not for today at least. So let's have a look at this step 2 already. If we look at some statistics of the type of backhaul that used to exist in 2010 and 2013 for the different cell sites. Here you have copper, microwave, fiber, hybrid fiber coax. You see clearly in areas like the US where cable operators are powerful, you have a lot of backhaul with hybrid fiber coax. And backhaul with fiber is going to increase. In Asia, due to the big growth of China and the 3G since 2009, a lot of sites are backhauled with fiber now. So a clear trend for more and more fiber backhauled sites. Of course, we clearly see now in mobile networks the commonalities of fiber to the home and connecting a cell. Because why? I mentioned the femtocell. The femtocell, really, it's like a customer termination because it has a coverage of 10, 20 meters inside buildings. But you also have more and more what they call the metro cells. Some smaller cells they can put on facade, on buildings, especially for dense cities. And those metro cells, they are pretty effective in terms of the cost. But you can kill the cost, but just a too expensive cabling system just to bring the backhaul to the metro cell. So again, this is the same idea of trying to think about solutions, cost-effective solutions to bring the backhaul capability and connectivity to the metro cells in dense areas. So really, we come to the same discussion of reusing right-of-ways as much as possible and trying to find some solutions that can help network operators, mobile network operators, deploy very efficiently their metro cells. I'll circulate here and give some more details. we've discussed about compactness this morning and how many fibers we can pack in a 23 millimeter cable. We can pack 1,728 fibers. Here you will have much less fibers, but extremely big conductors. Those are typical cables that we've made here for the front hull, so the connection between the base station and the remote radio head. On top, for three sectors, you have your antenna and three sectors. You have the 6 corrugated coaxial cables of, I would say, the 2G or the legacy infrastructure. And you have 2 ways to bring the fiber to the remote radio head. Either you are using a simple optical fiber cable, a riser, I would say, typical riser, then depends whether it is an indoor riser for rooftop coverage, rooftop antennas, or whether this is an outdoor riser for that kind of towers. And here, the power cables, or everything embedded in the same cable, like here, that we call the hybrid fiber to the antenna. Then it really depends on regions at this moment, operator strategies. For instance, in the US, we've been developing these cables that you see for T-Mobile US. And we worked with NSN to make, basically as NSN was proposing the base stations, the antenna, all the mobile systems, and then they took the cables from us. We have this very key expertise, be it in the US or here in this area or in Europe, to be #1 cabler, not only in telecom, but in our results. Energy is 80% of our turnover. So we are champions of energy cables. And bringing the two together, we can make those aggressive designs with conductors that are pretty big for telecom guys, but pretty standard for energy guys. And we put inside the tubes involving the latest band-insensitive fibers. So back to the beginning, band-insensitive fibers, some tube designs that we could use to make those cables a reality. We also won a project, Telkomsel in Indonesia, involving the equivalent type. So you see here the base station, duplex links, because basically this is a duplex connection from the base station to the remote radio head. So 2 fiber per base station, per sector, per remote radio head, equivalent powering. And then really depends on the type of equipment. We have a full range of size of connector we need to propose, the typical screening, insulation, the different options, whether this is indoor cable, outdoor cable, and obviously coupled with the type of optical connectivity they want to have. One of the cable that is circulated is 48 fibers. 48 fibers for a tower, I don't know, it's probably, I don't know, 9 sectors, or I don't know how many, but it's a lot of fibers for an antenna. Typically, this is more, I would say, between 8, 12 fibers. So many different fiber counts. The tube that is used can be either loose tube or flex tube, and again, several options for the sheath material. So either the parallel link, fiber or power, or the two in the same cable, hybrid cables. And again, this really depends at the moment. In the US, they are deploying a lot of these. We've been really successful there implementing these hybrid cables. In Europe, really depends. I have a cable here. So maybe because this is Europe, this is not the same size, but it is hybrid also. You have much smaller conductor and some optical fibers. This cable has been used in Italy. In some other countries, they are not really keen on, at this moment, moving towards hybrid cable, just because the installation crews need to have double expertise, optical expertise and electrical habilitation to manipulate hybrid cables. So it's a bit something that is starting. By the way, 4G has been in force since 4-5 years. So this is really something starting, something happening. And this is really a trend that we are accompanying through our electrical and telecom expertise.